Okay. Our next talk has the subtitle Exploiting the Unexploitable. So be ready for hardcore exploitation by Dimitri.
Hello everyone. Yes, my name is Dmitry Chastuhin, and today I would like to introduce you our new talk, Thanks SAP for the Vulnerabilities, or Exploiting the Unexploitable. So, and of course, the first slide will be about me. I'm a security researcher from a ERP scan company. In ERP scan company, I'm responsible for the different types of security assessment and penetration tests related with different ERP systems like SAP and Oracle, and also I'm responsible for some kind of research things related with SAP especially. And also I want to introduce my colleague. I want to mention about my colleague Dmitry Yudin. We both was involved in this research, and Dmitry is a ERP scans reverse engineer who helped me to solve some troubles and problems during this research. And of course, slide about our company. As I said, both of us work in ERP scan company. It is a security company which provide a solution for secure ERP systems like SAP, PeopleSoft, Oracle. We have headquarters in Netherlands, and also we have offices around the world, in US, in Australia, in Denmark, and also we found a lot of different vulnerabilities in SAP and Oracle, and made a lot of buzz about some of these findings. I think that's enough, and I have no slides with agenda, but I will try to explain what I will present to you. First of all, I will not tell you about how is important to spend some time and money on SAP security. I hope you know it's very important. Also, I will not tell you about SOD. I will not tell you about best practices, etc. It will be just a little story about how we got yet another way for getting remote cont execution on SAP server. And of course, I should mention our target is SAP. I hope all of you know what is that. SAP is the most of biggest ERP system in the world. A lot of worldwide known companies use that system, and I think that this information is enough. So let's start. What do we want? We want to get access to the SAP server, and as a result get access to the critical business data. How we can do that? Probably exist a lot of ways for that. We can try to attack a web part of SAP using a typical web attacks like cross-site scripting, CSRF, SQL injection, whatever. Also, we can try to use specific issues and problems of ABAP or Java stack of SAP system. For example, problems in RFC services in Java servlets, or mistakes in ABAP codes, missing authorization checks in SAP transactions. Or we can exploit some additional SAP services like Logviewer, SDM, SAP Notepad, or some archive issues. software download management, a lot of them. In our research, we try to find vulnerabilities on the binary level of SAP processes. And we decide to start with probably most important binary services. It's a SAP dispatcher services and binary file disp plus work. This file has a pretty big size, 51 megabytes, and of course, as reverse engineers, we tried to open these files in our favorite disassembler. It was, in our case, it was IDA Pro. It's a very popular debugger and disassembler, and as a result, we got a lot of assembler code. IDADB size was also pretty big, and of course we tried to debug this process, this plus work, but already on this step we got a problem because it was very difficult to debug network communication with dispatcher process, because this process creates a lot of child sub-processes. That's why, and every of these child can handle user request. So that's how it looks like on the server side. You can see SAP start process create another one, and this work process create a lot of child processes, and all these processes can handle requests from the user or from the other SAP services. So the problem is we should try to guess the ID of process for the attaching of our debugger, or we try to attach to each other process. It's a problem. It's really a problem. And also you can see another process. It's a GWRD. It's a gateway. ICMan. It's an Internet Communication Manager. JSTAR, etc. A lot of them exist on the server side. And we will try to solve this problem of big count of these work processes, and we try to reduce this count. And we change some SAP profile parameters. On the slide you can see what we change, but the most important is configurable underscore WP underscore no. We set it equals 0. That's how we got only one disk work processes, and that's how we can reduce the count of disk work processes. That's how we can easily attach by our debugger to this process. But actually, yes, we got only one worker. But if you look closely on the process list, you will see one thing. We lose our JSTAR process. That's how the process list looks before we change. We made the change in the profile parameters. JSTAR processes exist. But after the changing SAP profile parameters, JSTAR process is gone. But we don't care. We don't need it. We need these plus work processes. And of our research, we want to find a vulnerability which allows us to execute operating system level commands on the server side of SAP. So we need a remote command execution on the server side. But we spent some time for reverse engineering of this plus work, but we didn't find nothing high critically. which allow us to execute code on the server side, because this process, this binary file, this plus work is too big, we are too lazy, and a lot of functions should be analyzed. So we decide, or maybe it was really easy to find, but we can't. But we decide to change our victim. Maybe we can choose another binary file which is not so big and which allow us to do a quick reverse engineer a remote command execution. We try to choose another one. As I said, a lot of them exist, like Gateway, IC Manager, JStart, SAP Start, a lot of them. But no, we want something other, and we choose SAP Start SRV. It's SAP Start SRV. It's a binary process, binary file, which is a part of well-known SAP services, SAP Management Console. The service allows to SAP administrators to control and manipulate of any SAP instance. For example, SAP administrator can stop instance or restart it, get process list, read log files, etc. All these things administrators and attackers can do through the HTTP port using SOAP methods. A lot of SOAP methods exist. All these SOAP methods well known, and even in so popular exploitation framework like Metasploit exist a lot of models which allow you to exploit and use different SOAP methods. But one important thing, all in modern version of Management Console, all these methods require authentication. Next. Yes. A bit information about SAP Start Server binary file. As said, this service listen port, which number of the port depends on the instance number, and we choose this service because it has one interesting method, OS execute, which allows us to, guess what? Yes, it allows us to execute a command on the server side. But again, this command requires authentication. For authentication, we need to provide a username and password from the operating system. By the way, it's the first point. We found the entry point. We just need to solve one problem. We need to bypass authentication. Right. Okay, so, and we decide to look at in the disassembler and try to understand how authentication and authorization works in SAP Starter Server binary file. So we sent the HTTP SOAP request and found one interesting function. It's inside. It's a name with name is trusted internal connect. Looks like typically SAP Starter Server just check you just get username and password from user request and try to check it. But another part of checks it's called exactly this one function. And looks like in SAP system exist some services which also try to authenticate it on the management console from some internal things. So we decided to look deeper on this function, is trusted internal connect. And of course, we found something interesting. We found few hard-coded usernames. So these usernames not look like a normal usernames. It's pretty big. And what's interesting, it is not operating system level usernames. That means exists a way for authentication on the management console without having operating system level usernames. Of course, we try to find some information about these users. We found some information about first one username. It's some journal username which can be used for requests with a temporary logon tickets, but we didn't find any information about the second one username. So it looks like some backdoors maybe. And the second thing, what about password? The idea, yes, we have a way to execute a command on the server side. We have through the swap method os execute, we need for that username and password. We have a username, we need only password. Maybe password also is hard-coded, but of course no. We should understand how password for this type of users created inside SAP Starter Survey. For that, we go deep in function is trusted internal connect and found three interesting functions: GSF open SHM, GSF check SHM key string, and GSF close SHM. And all these three functions has common part SHM. What is that? Actually, SHM means shared memory. It's a special part of memory which allow to two or more processes share the data. For example, one process can write some data into this shared memory, and another one can read this data. So pretty comfortable. So let's try to understand what exactly this function do. Obvious, open SHM, just open SHM, shared memory. Close SHM, just closed shared memory. What about check SHM key string? Okay, go to the debugger, go to the disassembler, and try to understand what is the key. Is this key static, or we can guess this key? If not, it's static. Maybe we can just brute force this key. And now let me answer on the part of this question. First of all, what is the key? The key is exactly the password from these two hard-coded usernames, which allow us to authenticate on the management console services. Okay, that's good. Is this key static? No. It's a pretty random key which has a length of 36 bytes. And now we can guess this key because it is pretty long, and we cannot brute this key because it's a pretty random. So it looks like GSF check SHM key string function is pretty secure, and we cannot get password from these two hard-coded username, and looks like the game is over. But we didn't give up, and we tried to debug a little. We wrote a small Python script which tried to execute SOAP request with OS execute method, which used for authentication our hard-coded username and random password. In our case, it's blah, 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 blah. And we try to see in debugger what key is expected by SAP Management Console. And I will show you a quick demo. What happens? One second. Okay. We are logging into our SAP server and look which process listen port 50013. In our case, it's a process SAP start SRV with PID 3825. And we attach using our debugger to this process, set few breakpoints, one on the GSF check SHM key string function, and two other breakpoints on we got one breakpoints and two other breakpoints on memcmp function, which allow us to be on the place where the binary file try to compare our password from our script. It's a blah 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 password, and try to compare this password with expected by Management Console services password. So you can see on the register RDI contains our password from the script. It's our key. And on the RSI, expected key. And if you can see, key is XAAAAAAX. And this key do not look like a random key. So it's pretty strange. But it's a good sign for us, because back to our presentation, 1 second. Yeah. So random SHM key string is X33AX. It's not look like a really random key. It looks like it's a very predictable key, and it's very good for us because probably exists some situation when the random key is not so random. So now we have the situation when we can execute operating system level command through the SOAP request. We have a hard-coded username, and probably we have the situation when the password for this hard-coded username is predictable. So our next goal is understand why the key for the hard-coded usernames is not random. For that, we should understand how exactly key was generated. For that, we look deeper on the SHM key string function. I understand. First of all, this function read the raw key, it's a binary key from shared memory. After that, this function converts this binary key to the readable format and add chars x to the end and the beginning of the key. We don't know why. Maybe for the correct size. And after that, check the key with user input, and everything. If everything is okay, access is granted. In our case, raw key from the shared memory looks like that. In shared memory, we found only zeros. That's why our function converts all these zeros into AAA, and after that add X at the end and the begin. Looks like some processes which should work on the SAP server side did not wrote some information on the shared memory, which allowed to the SAP start SRV generate correct key. So yes, it looks like. And our next step, it was understand which what the process responsible for that action, which process should wrote correct information in shared memory. And we try to guess what the process is, and after that we think about one thing. Do you remember we did some change in profile parameters for reducing count of this plus work counts? And as the result of this changes, yes, count of the process was reduced, but also we lose our G-start processes. And we decide to change back all profile parameters. We commented all these parameters and restart the system. And as a result, of course, after that, G-start process successfully started, and password for hard-coded username became random again, and the key and the password XAX is not working, and this is strange. So it means we can execute a command on the server side if we can change some parameters on of the SAP's profile parameters. Or we can try to do another way. Maybe we can try to just try to stop G-start processes. For checking this idea, we wrote another Python script which tried to authenticate on the server side on the SAP Start SRV services with hard-coded username and with password XAAX and in the cycle. And as payload for OS execute method, we put a reverse shell. And after that, we decide to try to kill G-start process now only on the local. And if everything is okay, after using command, we try to kill G-start using command kill all command. And if everything is okay, our on the small time password for the hard-coded username should be XAAX, and if it's true, our script will successfully authenticate, and we will get a reverse shell. But of course, nothing. It didn't work, and again the problem. Okay, we again didn't give up. Time for plan B, and we think, what if not only G-start process is responsible for the putting correct information to the shared memory? Maybe exists some other process which also responsible for that. And we think maybe it is IC manager. It's an internet communication manager. And why we decide to choose internet connection manager as a new goal? It's just our intuition. So the new plan is plan B is again run our script, which allowed to in the cycle to authenticate on the management console using hard-coded username and magic password XAX. And after that, we try to kill IC Manager and restart locally. One more demo. Okay. So we log into our SAP system. Okay. Now on the attacker machine, we launch, we listen port 444, which waiting connect from the reverse shell, and we run our script in the cycle, which try to authenticate with magic password and hard-coded username. After that, on the server side, we run command kill all, which allow us to kill IC Manager and G-star processes. And as a result, we got a reverse shell. That means on the it was exactly what we expect. On the few seconds, the password for the hard-coded username was XXAA. It's pretty good. That's how we can get a reverse shell. So, new plan. We need to solve one more problem. Yes, we can run in the cycle our script, which try to authenticate, but we should kill IC Manager and G-star process remotely. For that, we need to find remote denial of service vulnerabilities for G-star and denial of service vulnerability for IC Manager. And start with G-star. It's the application server for Java. This binary file responsible for the Java stack of SAP. And yes, we found denial of service issues for G-star binary for G-star processes approximately after 3 days of fuzzing and research. It was possible race condition. What interesting, an attacker can send few special requests on the G-star port, which will trigger the vulnerability, and G-star will crash. And what interesting, after crashing, G-star start again. It was pretty easy. So that's how, on the slide you can see the part of the request which can trigger the denial of service attack and information about crash dump. The next things, we need denial of service vulnerability for internet communication management. It's only one step between us and remote command execution. Yes, internet connection management. No, yeah. What is internet connection management? It's one of the well-known services of SAP, one of the core services which provide access to some SAP functionality through the HTTP request. And yes, some information about binary file which is responsible for this services. It's not so big, around 6 megabytes, and because it's one of the core components of SAP, it's heavily audited. First of all, we tried to find some public information about vulnerabilities, denial of service vulnerabilities in ICMN. We found one. It's a denial of service attack. The latest was in 2014, without any details how we can trigger it, etc. So we should found new one. And looks like it will be not so easy as in Gstart case, and after 35 days of research and plus some weekends, yeah, we found one issue which allows us to trigger denial of service attack. It's on the screen. You can see part of request which can crash ICMN services, and also you can see the crash log, and again ICMN services restart after crash, which is very useful for us as an attacker, because if we try to use, for example, this type of vulnerability in penetration test and we stop some business processes in companies, it will be very bad. So in this case, in this denial of service attack, it was again race condition, which allows us to kill IC manager, and as a result, we have all pieces of our puzzles for our remote command execution attack. The finally plan, the finally chain of exploits looks like we run the Python script which try to authenticate on the management console services using hard-coded credentials with magic password XAAX in cycle, and execute swap method OS execute with payload, which will return reverse shell. After that, we run two scripts. One will kill gstart. The second one should kill IC manager services, and it probably should work. And finally, demo. Yes, we launch on our laptop netcard, which listen port 444 for reverse shell. Run script which kill IC manager. Run script which will kill gstart. After that, we launch our Python script which try to execute OS execute swap method, and we should get reverse shell. Yeah, we got the reverse shell without any authentication. Without any username password, fully remotely. Now we can try to get, yes, we got access to the server side on the operating system level, and we can try to escalate our privileges on the SAP level. It's very easy in our case. We just try to read, for example, Java security storage. We open port on the server side through our reverse shell, which allows us to download two files, sextor.properties and sextor.key. It's two files which contains sextor.properties contains encrypted information about administrator password and connection string to database, and as said, it's encrypted information, but in the same directory SAP stores file sextor.key with key for decryption of this information. It's pretty easy to download these two files. We know the algorithm of encryption. We decrypt this information and got administrator password and can successfully use it for logging in. Instance number. Yeah. Enter username, SAP star in our case, and password from the security storage. Hey, yeah, we are SAP star. Okay, back to our presentation. Yeah, finally on the slide you can see solutions. SAP released few nodes, which actually they released it maybe few days ago. It's these nodes close denial of service vulnerabilities and probably authentication bypass. Maybe we should try to check how they did it. Maybe some mistakes still exist. And as a conclusion, I want to say for the security researchers, do not give up. If you can't exploit some vulnerabilities using one issues, try to find another way to trigger the same issues, and you probably will get the result. And for SAP administrators, you should know even not so critical vulnerabilities like denial service or on the first look unexploitable hardcode credentials can be very dangerous because an attacker can use a chain of exploit for getting access to the system. I think because in the past attacker can exploit SAP system using just one GET request to some Java servlet which allow him execute any operating system level command without any notification. In the present, an attacker used a chain of exploits, and as you can see on the previous talks, all guys use a chain of different issues for getting access to the system. That's why it's very important to look closely not only high critical vulnerabilities and also to try to correlate different issues and try to understand how they can affect the system, and of course implement all security nodes to your product system. And of course, for everyone, have fun with your recipe installation. So thank you very much. If you have any questions, I will answer it.